Good afternoon. My name is Andres Tewen, and together with Gerardo Urdaneta and Lauren Rogalski, we're going to talk about RL, RC, and RLC circuits. The main objectives of this presentation are going to be explain and understand different components in a circuit, including resistors, capacitors, and inductors. Describe how the components work, understand the uses of the components in a circuit, and the interactions between them, and comprehend the mathematical expressions of this type of circuits. For relevant questions that we came up throughout the project are: what are resistors, inductors, and capacitors and their applications? How are the resistors related to the capacitors and inductors? And how are the expressions for RC, RL, and RLC derived? First, let's talk about the definitions. A resistor is a component that limits the current flow in an electrical circuit. Therefore, the measurement of this opposition is called resistance, and it can be expressed by Ohm's law, in which V equals I times R, where V is the voltage, I is the current, and R is the resistance. Now for inductors, they are two-terminal components that store energy in a magnetic field, created by the current going through the inductor. The expression for inductance is L equals phi over I, where L is inductance, phi is the magnetic flux, which is the strength of the magnetic field, and I is the current. Now, for how do these components work? Well, many resistors are made of a ceramic rod that is wrapped around by a copper wire. The more the copper turns and the thinner the wire, the harder it is for electrons to move throughout the resistor, and consequently, the harder it is for electricity to flow. For how inductors work, well, as we said before, inductors store energy in a magnetic field. This is produced by the movement of charges through the wire. So if this magnetic field varies over time, an electric current will be produced according to Faraday's law. This in turn will produce an induced voltage, which will keep the current flowing through the circuit, even if there's no voltage or current source. Now let's look at an example of how the inductors work. In this case, in this circuit, when current flows, the coil of the inductor resists the flow of the current at first because it is building a magnetic field. But once it is built, current will flow normally. Now, if this circuit is open, the energy from the magnetic field is going to change, which is going to produce that induced voltage, and will keep the current flowing, which in turn will keep the light bulb on. Now, let's take a look at where the mathematical expression for inductance is coming from and how it is related to the current and resistance. In this case, we have a circuit with a voltage source in series with a resistor and inductor. So according to KVL, the addition of these voltages is going to be equal to 0. Then we replace the voltage across the resistor for I times R according to Ohm's law, and the voltage of the inductor for the inductance times the change in current over time. After that, we solve the equation for voltage, and then divide the equation by inductance, resulting in a first-order equation. After solving, we get that the current is going to be equal to the voltage over the resistance times 1 minus e to the negative resistance over inductance times the t, which is time. From this equation, we can see that if the resistance is increased, the current is going to approach to 0. So it is going to reach the steady state value, or the plateau, faster, which is when no more current is flowing through the circuit. On the other hand, if we increase the inductance, it is going to take longer to reach this steady state value. So the current will keep flowing for longer throughout the circuit. Now I'm going to leave you with my friend Lauren to explain about RC circuits.
Now we're going to talk about RC circuits. But before we do that, it's best to know what C in RC actually stands for, which is capacitor. A capacitor is a two-terminal component separated by an insulating material that stores electric charge. The ratio between the stored charge and the voltage is called the capacitance. How does a capacitor work? Well, a capacitor is made of two metal plates with a dielectric material between each plate. When a voltage is applied to the two plates, an electric field is created which then stores energy. The capacitor is then described as charged and can emit energy to other branches in the circuit, like resistors. What are they used for? In an RC circuit, capacitors help to store power and charge, which is useful for when one has to use a small amount of energy when needed, like when there is a power outage, and there's stored energy there that can keep something running for a duration of time. Examples of RC circuits, things that use RC circuits in life, are windshield wipers, an electric toothbrush, and an alarm clock. RC circuits use KVL, which is a summation of the voltages in the circuit. As we can see in this circuit to the right, V1 is represented by just a V, and the voltage across the resistor is R times I, and then the voltage across the capacitor is represented as Q over C. We then solve for V, and then I gets replaced by dq over dt, and then rearrange the equation to get V over R. And then these two equations at the bottom are the differential equations.
Hello, my name is Gerardo, and I'm going to talk about RLC circuits and what are they used for. So a common application of an RLC circuit is tuning radio, basically. For instance, when we tune a radio to an exact station, then the circuit will set a resonance for that specific carrier frequency. What this is saying is that when you're tuning the radio, basically you are telling the receiver to look for a specific frequency of a specific wave. Therefore, the transmitters that are emitting that specific frequency are going to be catched by this receiver. Therefore, you will be able to listen to just one radio station instead of several at the same time. Another uses for RLC circuits are voltage magnification, when its components are organized in series, and when they are organized in parallel, you will have a current magnification. Here we have an RLC circuit in series with a voltage source, and to understand the mathematical expressions for RLC circuits, I opted to use this form because it's the most basic one. So by using KVL, Kirchhoff voltage law, we have that the voltage drop through all its components have to be equal to 0. Therefore, the voltage here will be equal to I times R, which is the voltage drop through the resistor, minus Q over C. Q over C is just the voltage drop through the capacitor, minus L times the rate of change over time of the current, which that gives us the voltage drop through the inductor. Basically, what I just did here was just replace each of these voltage drops by their specific equations. So by organizing this equation in this way, we have a first order differential equation that we cannot solve because we have two unknowns, which are I, the current, and Q, the charge. The good thing about this is that we know that I is dq over dt. It is just the rate of change of Q over time. Therefore, we can change I by dq over dt. Similarly, we can do the same thing for di over dt. where the first derivative of a derivative if it is just the second derivative. So we're gonna have just a second derivative of q. So we have this differential equation where L, R, and C are constants, and q is the expression we want, and b is also just a constant. When we solve this second order differential equation, we can have three possible solutions depending on what this expression is. If this expression r squared minus 4 times L over C is bigger than 0, we're gonna have this expression for the solution of the differential equation of the charge over time, and it will be just an exponential function. The same thing with this one. If this one is equal to 0, this expression is equal to 0, the charge over time, it will be similar to the first case, but a little bit different. The point is that these two are almost the same because their behavior will be exponential, and most of them, they diverge to infinity when t goes to infinity. However, the good part about this expression right here, when r squared minus 4L over C is less than 0, is that q respect to t will be an exponential function, but involving trig functions. Therefore, one example of this expression is this graph, which tells you that the charge in this circuit will go down, alternating between values below 0 and over 0, and it will decrease in an exponential way. But the good part about this is that this is converging over time. Therefore, we can use this expression when the resistance square is bigger than L over C times 4 to use this RLC circuit as a filter of waves. What the tuning radio is doing is that you are setting a specific frequency and a specific wave that you want to look for, just to be able to listen to that radio station. So the RLC circuit will find these kind of functions and will give you the function that you want to look for, that you are looking for, and will throw away the other ones. And as a conclusion, is that RL, RC, and RCL circuits consist of components that help to regulate and improve the supply and transfer of energy in a circuit. These circuits are seen in many things in today's world, therefore their importance, and have created an undeniable efficiency and improvement for the electronic industry, the electric industry, and for life itself. That's why I think it's important to learn more, at least a little bit more, about these kind of circuits, because they are everywhere, from the screen of your phone to the transformer outside your house. So it is really important to know about these circuits. And well, thanks for your attention and have a good day.